So 5.4b, polynomials in intercept form. Yesterday we did standard form. Today we're doing intercept form. Anyone know another name for intercept form? Intercepting form? No. Factored form. Remember the last test, you had to factor a bunch of stuff? Let's see if we can zoom in here at all. The entire purpose was factoring your equations so that way you could come up with the zeros. Do you remember that? Yes? No? Yes? Okay, good. So this is what it looked like when you had it in factored form, correct? All right. So you would take something like this equation right here. You would come up with your possible zeros. You would start factoring by using synthetic division and then finally get down to an x squared and factor it. They've already done that for us, because that takes a lot of work. Now, from here, what would you do?
Find the zeros.
Find the zeros. So what do I get from that parentheses right there?
1.
X equals positive 1. What do you get from here? Do either of those have a multiplicity of greater than 1? They both just happen one time, correct? If you look at the graph, and my hole puncher strikes again because it's right where I need to show you, but here is where x equals 1. Over here, where it would cross, would be where x equals negative 2, correct? And we just have a straight, it's crossing through the x-axis right there. I'm going to call that just a cross, meaning that at those two zeros, my graph crosses through the x-axis from bottom to top or top to bottom. Okay? What have I got going on here? I have it factored, but it has that little squared thing right there. So what does that mean? When I have x equals 1, I have a multiplicity of 2, also known as a double root. Okay? So if I look at the graph where x equals 1, that is not the same as this cross right here. It's not going from top to bottom or bottom to top. It's coming up, it's hitting the x-axis and going back, isn't it? I call that a kiss. It's kissing the x-axis. Okay? And then this last one over here, I have x equals 1 still, but what's different about this one? Multiplicity of 3. And how does that picture look different? Here's 1. How does it look different than the previous ones? It's clearly not a kiss because it's going from the bottom to the top, or it could be going top to bottom. But how is it different than the multiplicity of 1? It's got a wiggle. Yeah? That wiggle has a special name. It has an inflection point. Remember we learned that when we were doing cubics? So a multiplicity of 3, like a cubic, has an inflection point. So the entire purpose of what we did yesterday, actually let me step back for a minute. If you wanted to graph something, let's say you wanted to graph an x to the 4th equation, a 4th degree polynomial. Really the only way to get an accurate graph is to do it on a computer or a graphing calculator. That's the only way you can get a super accurate graph. If you were to graph it by hand, you don't know if all of the bends that we talked about, you don't know if all of these bends are happening between -1 and 5, or if they're happening between 21 and 30. You really have no idea. The only way you would find out is if you had a super long XY chart and just started plugging values in. And you could end up plugging in 20 values before you get anything of meaning with that. We don't want to do that. That's really tedious, which is why we started with the sketches. And now today we're going to take it and we're going to get one level more accurate. We're going to take those sketches and give them a little bit more accuracy by using these x-intercepts. So looking here, I have something in intercept form. Yes? Okay. Is there a 0 right there? No. No letter, no 0. Right here, I have a 0 of x equals -1. What's the multiplicity? 1. Don't have to worry about it. Are any of these going to have a different multiplicity? No. Nope. So I have x equals -1, x equals +1, and x equals -2. All right? Now, leading coefficient and degree. Leading coefficient and degree you always get from the first term when it's in standard form, correct? Now, I don't want to have to multiply all this out to get that first term. Okay? So I can kind of simplify it. The way you would get the first term would be whatever's out in front times the first thing in each parentheses. So 4 times x times x times x would be 4x cubed, correct? That's my first term. So the leading coefficient, I'm not concerned about what the number is. I'm concerned about if it's positive or negative. Well, if my first term is 4x cubed, my leading coefficient is positive. Okay? All right, so let's take this positive right here. I'm going to go down, and what I'm going to do is on this XY chart, or on the axes, I should say, I'm going to give the x-axis some points, or some little dash marks to signify some points. So I don't need too many, because the only numbers I'm going to be concerned with are -1, 1, and -2. And then on here, I'm going to put a point at -1, +1. Whoops, I just plotted at -2, didn't I? Good thing that -2 is the other number I need. So -1, +1, and -2, because those are my x-intercepts. So I know in general a third degree, which we just talked about, how you have 4x cubed. We have a third degree, is going to have 2 bends in it, right? I know that the right side is going to go what direction based on my leading coefficient? Is going to go up. Now, I'm going to be more specific with where it's going up. Since I know where it's crossing the x-axis, I'm going to look at what's furthest to the right, the 0 that I have that's furthest to the right, and nothing beyond that is going to be any bends, or at least no bends that are going to affect the x-axis. It's just going to go up there, because that's where my leading coefficient positive, right side goes up. Since it is a third degree, that means it is odd. So what does that mean about the left side of my graph? It's going opposite, so it's going down. So on the left side of the 0, we've got it going down. Now, all of these were just the cross situation, right? I didn't have any kisses or inflection points. So this is going to cross and go up. But if it has to cross the x-axis here again, what does it have to do? It has to turn around at some point and come back down to cross again. Right? And if this end is going up, doesn't this have to turn around again at some point to get that? So here's my bends. I just gave a little bit more placement to those bends by incorporating those x-intercepts. Does that make sense? There's still a part that's not very accurate, though. I don't know how high this one goes or how low this goes. So that right there and this right there is still an estimate, but at least this part is more accurate than it was. Okay? So let's look at the next one. Over here. Is there a 0 right here? No. No x, no 0. What is the 0 I get from this parentheses? X equals -3. Is that a cross, a kiss, or an inflection point? Cross, because it doesn't have a multiplicity of 2 or 3. That makes it a cross. This one right here, I get x equals 2. Is that a cross, a kiss, or an inflection point? Because this has a multiplicity, oops, multiplicity of 2. We have a cross and a kiss. So let's get those points on here. -3 and +2. So let's see, I need -3 this way. And I need +2 this way. Okay. Let's talk about the leading coefficient. Actually, let's talk about how I would get the degree first, just to make sure that we're clear on this. Now, The degree, I know some people were having difficulty with how to calculate the degree before when you have it in factored form here. Now keep in mind, factored form here would actually look like this if it was written all out. You would have x minus 2 and x minus 2, correct? That's what the squared means. So if I were to multiply the first thing in each term, or in each parentheses, to find that first term, I would have negative 1/6 x to the third. Okay? Now if I can see that from here, great. Use it. But if it helps to think of it like this, then go ahead and write it out. So what does that tell me? My leading coefficient is negative. And what does that tell me about the degree? Third, which is odd. Okay, so if I have a leading coefficient that's negative, what does that tell me? The right side goes down. So from the 0 that's furthest to the right, we're going down after that. Since I have an odd degree, what does that tell me about the left side? It's going opposite, odd opposite, right? So it's got to go up. Now, at negative 3, we determined we have a cross, so it's just going to cross through the x-axis there. At 2, which is this 0, we have a kiss. So if this side is below the x-axis, it's going to curve around and this side's also going to be below. It's not going to actually cross through the x-axis. Does that make sense? And then I just got to connect these two ends right here, so at some point that's got to bend and come back up there. What's the only part that's still inaccurate on that? I don't know how low that goes. It could just be like a nice shallow one. It could be even deeper than that. I don't know. But I know this and I know that, so that gives me a better picture of what the shape looks like. Okay? All right, let's look at this guy. What is my 0 from there? There's a letter outside. There's an X outside, which means there's a 0 there. Does anyone know what it is? It's x equals 0. It's not going to be 1. If it was 1, it would have to have a parentheses with a 1 in it. But since there's nothing in it, you just set it equal to 0. Okay? What do I get from here? X equals what? 3 with a multiplicity of what? 3. So this one has no multiplicity, or we could think about it having a multiplicity of 1, which means it's going to be a cross. What's this guy going to be? An inflection point. All right, my leading coefficient, again, I got to think about it. If I were to write this whole thing out, x, and then x minus 3 would happen 3 times. That's what to the third power means. If I multiplied what's out in front by the first one in each parentheses, I get x to the 4th, correct? So the rest of standard form would come after that. I'm not doing all of standard form. That just tells me what the first term is. Because from there, I can get my leading coefficient, which is positive 1, and I can get my degree, which is even. That's the only term I'm concerned with here. Okay? So. Let's plot our points, 0 on the x-axis and 3 on the x-axis. All right, leading coefficient is positive. What does that tell me? Starting at the 0 that's furthest to the right, it goes up. I have an even degree. What does that mean? The left side also goes up because it goes the same direction. Okay, and now, let's see, at 0 we have a cross. So it's just going to cross straight through the x-axis there. What do I have at 3? An inflection point. So this is actually going to curve something like that right there. and then I have to connect those two ends, so at some point it's going to curve and come back up. And that's what my fourth degree equation would look like. Okay, so? Okay, now what's the part of this graph that's still not accurate for me? How low it goes. I don't know that. Okay, so for part of your homework tonight, in fact, I think it's the first two problems on each side. First problem, I'm looking for something like this. Draw an XY chart, but you only need to put values on the X side. Y side, we're not worried about right now. Okay, so for 1 and 2, and on the back side, 7 and 8. All of the rest of the questions, a graph is provided, and I'm going to want you to do those the same way we're going to do these guys right here. Okay? Now, before I get to these guys, I had a couple questions about end behavior. So let's do the end behavior on these three graphs, just so that we know what we've got. Now, for end behavior, this would already be typed in for you. You just have to fill in the end with what? Whoops. I didn't mean to write the infinity there. I will eventually. Do you have my whiteout? Whiteout. Thank you. Okay. So you are given that for end behavior, right? Yes? No? Okay. This statement right here, as x approaches infinity, think about your x-axis. What side has a bunch of big positive numbers on it? Is it the left side or the right side? The right side. So this is saying, look at the right side of your graph. Or another way to think of that is, look at the arrow that's on the right side of your graph. So if this is my graph, which arrow's on the right? That guy. So this tells me which arrow to look at. This tells me what direction is that arrow going in a y direction. So is that arrow going up towards positive infinity or down towards negative infinity? Up towards positive infinity. This one right here, when I have x approaches negative infinity. Well, on my x-axis, that's the left side, so this is a fancy way of saying look at the arrow on the left of your graph. In other words, look at that guy. Where's it going up and down? It's going down, so I would fill in the negative infinity there. So the first part tells you whether you're looking at the arrow on the left or the right. The second part, you're telling me, is it going up or down? So? Let's do this guy. X arrow infinity, comma, y arrow blank. X arrow negative infinity, comma, y arrow blank. So, x arrow infinity, is that asking me about the arrow on the right or the arrow on the left? Positive infinity would be on the right of my x-axis, therefore it's asking for the value of the arrow or the direction of the arrow on the right. Where is it going? Down. Negative infinity for x, that's asking about the arrow on the left, so it's going up. Remember, odd degrees go opposite, so once you know one, the other one is opposite. This one, is this one an odd degree or an even degree? Even. We like evens because even if I don't understand what this says, both ends are going up, therefore both statements are going to be positive infinity, regardless of if it's talking about the arrow on the left or the right. Okay? But the positive infinity one, again, is asking about the arrow on the right. The negative infinity then is asking about the arrow on the left. Okay? So? All right. So let's take these graphs and make them one step more accurate. I said the one thing that wasn't accurate about it was how high up or how high down it goes. So we're going to take this problem. This is actually the exact same equation as this guy. So we're going to take this graph and make it one step more accurate. So I already know a lot about this graph. I know that I have a 0 at -1, at +1, and at -2. So I'm going to go ahead and plot those. Right? I know that from the graph above, the right side goes up because my leading coefficient was positive, and the left side goes down because I had an odd degree. What was the degree of that one? 3. So again, this is the exact same equation as we used in this example. Now, if I want to know how high up this goes, or how far down that goes, how could I figure that out? That's where the XY chart comes in. Okay? I'm not going to do a super long XY chart, but I want to know between these two zeros, how high up does it go? So what would be a number between those two zeros, an X value, that would be good to investigate? If this is -1 and this is -2, how about we look at -1.5, because that's halfway between them, right? If I plug in -1.5, I'm going to plug this one in the old school way where I just plug it straight in. 4 times -1.5 plus 1 times -1.5 minus 1 times -1.5 plus 2. I get 5/2, which ends up being 2.5. So I just found that the point -1.5, -1.5, comma 1, 2.5 is on my graph, which means that I just found out a height there. Do I know that's exactly how high it goes? Not necessarily. It might go higher. Maybe at -1.75 it goes higher and it's on its way back. But I do know that however high it goes is going to be pretty close to 2.5. So this is taller and skinnier than it was here, isn't it? So a little bit more accuracy. What if I wanted to know how far down this goes? I got to pick an X value that's between here so I can see what's going on between there. Well, between -1 and 1, let's pick 0. And I think I showed you this the other day, but if I didn't, you can just arrow back to the left, delete all those -1.5s, and plug in 0. So you don't have to retype everything. Just delete those -1.5s and plug in 0. And hit enter again. It goes all the way down to -8. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Goes a lot far down than I estimated, didn't it? So yesterday we had something that we knew what direction the ends went and we knew how many bends there were. Then we went here and we knew what direction the ends went. We knew how many bends there were, and we knew approximately how wide the graph was because we could plot our x-axis, our zeros on it. And now we can even see approximately how high or how low it's going in between. So this is the most accurate that we're going to get with these. Okay? Yes?
On the test or quiz or whatever, is he gonna like tell us to do that?
The instructions will say something about estimating a local maximum or a local minimum. That's what we call these guys right here. And there'll be an XY chart provided, so that will be your indicator. Hey, put a couple of values on there.
If it doesn't, we don't have to do that.
Right. Okay. All right, so let's look at this. This is an odd degree. What's my domain? What's my range? I think my range is all real numbers, right? With an arrow going up and an arrow going down, we got all real numbers. Because even though I stopped this graph here because I have a hole punch right there, it goes on past that -8, doesn't it? Okay. All right, and now we have end behavior. X arrow infinity. Is that asking you to look at the arrow on the left or the arrow on the right? Right. What direction is it going? Up. And X arrow negative infinity is asking me about the arrow on the left. So on the left, we are going down. Easy peasy? All right. This last example is the exact same equation that we used in this graph right here. So again, we already know information about it. We already know we have a 0 at 0, and we know we have a 0 at 3. 0 and 3. We know that both ends are going up because we have a positive leading coefficient and an even degree. So I can start with that. Now, I want to know what's going on between so that I can find out approximately how low this goes. Now, I could pick one value, but I think I'm actually going to pick both of those numbers, because if I pick both 1 and 2, that'll help me get an idea of what this bend is going to look like also. Okay? Now, I could pick numbers outside of there, but for our purposes, we don't really care. We just know that it's going up there. All right? So let's plug in 1. If I plug in 1 into this equation, 1 parentheses 1 minus 3 to the third, I get negative 8. So at 1, 1, 2, 3, 4, 5, 6, 7, 8. Goes all the way down there. That's a little further than I estimated. And now I can go back. Again, you can just arrow to the left, delete those 1s, and put a 2. And I get negative 2. By the way, if you have one of the Texas Instrument calculators, I know a lot of people have this calculator right here. You can still do that arrowing back thing. You would arrow back. You just highlight the previous number and type over it. You don't hit delete on that one, actually. Okay? So play around with that. Okay, so let's see. 2, negative 2. That helps me get a little bit of an idea of what this inflection point looks like. It's pretty steep right there, but then it kind of has to bend kind of quickly to get to there. So it's not a super dramatic inflection point, but it is there. So again, taking this and making it a little bit more accurate. What would you say is my domain? All real numbers. What would you say is my range? Now I can estimate a range. Negative 8 is not a range. Negative 8 is a number. How would I state the range? Y is greater than or equal to negative 8. Or I could say, I could do a square bracket and say negative 8 comma negative 8 comma infinity. Or I could say negative 8 is less than or equal to y is less than infinity. I could write it any of those ways. Okay? Is that an actual range or an estimated range? Estimated, because I don't know if maybe it goes a little bit below there and comes back up already or what, but I know it's going to be around there, so it's estimated. Lastly, we had an even function, so both ends are going up. I can just throw in a positive infinity and a positive infinity, and I've got it done. Okay? All right.